Hello everybody, today's unit is going to start off with the basics of matrices. A matrix is an array of numbers, and I've got an example drawn here. So it's got square brackets and then a bunch of numbers on the inside, and basically a matrix is a way of condensing data into one place. And this is going to be helpful because then we could add or subtract or multiply them in order to solve for different items. And this is basically an alternative to solving a system of equations. So for example, before we would have three equations, we'd have to do elimination or substitution, and then we'd solve for x, y, and z. Here we eliminate the variables, and now we just use the numbers to do the calculations to help us get our final answer. So this is just an alternative in order to solve for missing items, okay, or to calculate larger numbers. When we deal with matrices, there are different dimensions that we're going to be working with, and the easiest way to identify its dimensions, or its size, in other words, is to always look at the rows and then the columns. So think of it as telling you the size of something, so we'll have to look at the number of rows, then put the x, and then the number of columns. So for example, I might have matrix B here. I'm going to list it with these numbers. So there's my matrix, and I would count how many rows there are. Rows go horizontally, so this is row 1, row 2, and then row 3. So this would be a 3 by, and then I look at the columns, which are vertical, so column 1 and column 2. So this is going to be a 3 by 2 matrix. Okay. And knowing the dimensions is going to be extremely important as we start in with our basic operations. The one up here at the top, we'll call this matrix A. This would have 3 rows and 3 columns, so this would be a 3 by 3. And when the dimensions are the same, we call that a square matrix. So I'll put that right here. Okay. If they're not the same, it's not a square matrix, and then you just work with it like normal. Okay, so same dimensions, square matrix, always rows and then columns. The next part that's going to be important is the elements within those matrices. An element is just one number or letter inside the matrix, and the easiest way to identify those is to use the letter of the matrix. So in this case, I'll look at matrix B, and then I list the row and the column that I'm looking for. So for example, if I wanted to look for number 4, negative 4, I would say it's in row 2, column 1. Okay, so I would go to row 2, look in column 1, and that would tell me my answer is negative 4. Okay, so it's one number or one letter within the matrix, using the rows and columns to identify it. And also when we name matrices, you always want to use capital letters, so that way you know which matrix you're referring to, especially if you have a list of 6 different matrices, you may not know which row and column to look in, so always use that capital letter. So now that we know the basics of the matrix, dimensions, elements, how we name them, now we need to know what we do with them. So the things we're going to start with first are basic adding and subtracting. The key here is that the matrices must be the same dimensions. So if they're not the same dimensions, then you would just write that you can't add or subtract, or that it's not possible. In this example here, we have a 2 by 2 and a 2 by 2 and a 2 by 2. So since they're all the same dimensions, we know we can subtract them, and then all you have to do is just match up each element. So for example, the first element here, 5, and this first element and this first element are all going to be subtracted from each other. So that's like writing 5 minus negative 6 minus 5. So if I do that, 5 minus a negative 6, that's 11. 11 minus 5 gets us 6. So when I write my matrix, my new matrix, the first element is going to be a 6. Okay. Then I do the same thing for the next elements. Go to the top right, and I'm going to subtract those together. So I'd have 3 minus 0 minus 4. So 3 minus 0 is 3. 3 minus 4 is negative 1. Notice that I put it in the same location as the numbers I was working with. So this is in the row 1, column 2. So my answer goes in row 1, column 2. And then I move through the rest of the matrix. These bottom left go together. So 5 minus 1 minus negative 2. I get 4 plus 2, which is 6. And then finally, my last element, 1, negative 4, and negative 6. So 1 minus negative 4 minus negative 6. So this becomes 5 plus 6, which is 11. And when you add or subtract, your final matrix should be the same dimensions as your original matrices. If it's not, then you've got an error somewhere with the way you calculated your numbers, but always should be the same. Okay, so if you have any questions about which numbers I'm subtracting or adding together, make sure you let me know. But you can write out each element like I did, or just circle or highlight as you go through to make sure you're matching up the right numbers. Okay. Scalar multiplication is just a basic multiplication technique. A scalar is just a number. Okay, so in this example, that negative 3 right there is my scalar. And what you're going to be doing is just taking every element in your matrix times that number. So what we would do here is think of it like PEMDAS. Multiplication comes before subtraction. So I'm going to multiply everything in this second matrix by negative 3, and then I can go ahead and combine them together. So when I do this, I'd leave the first matrix alone, negative 2, negative 6. And then if I distribute and multiply each item by negative 3, I'm going to get in my matrix a positive 18 and a 0. And now I can go ahead and add my two matrices together. Negative 2 plus 18 is going to be 16, and negative 6 plus 0 is still going to be negative 6. So my final solution is this 2 by 1 matrix with 16 and negative 6 in its elements. So if you have any questions about addition or subtraction or how to complete scalar multiplication, let me know. But you're going to have quite a few practice problems where you can make sure you're on the right track. The only other thing in this section is going to be using our elements to solve for missing variables. So here we've got two matrices. Both are 2 by 3s, so 2 rows, 3 columns. And what we want to do is figure out what the x and y variables are using the fact we know these matrices have to be the same. So this is just a way of identifying which elements go together. So if I look in my row 1, column 1, this equation here has to match up to this 12. So to solve for x, I could just write a little equation. 2x plus 4 has to equal 12. And now it's just an equation of a line. You solve for x, subtracting 4 to the other side, we get 2x is equal to 8. And then, excuse me, divide by 2, you get x is equal to 4. So there's our first solution. And then do the same thing for the y value. So take this equation, which is in row 2, column 2, and set it equal to this same matching element. So negative 3y plus 5 will have to be equal to 5y minus 3. And then you could go ahead and solve. So try to do that one on your own. That's about as complex as the equations will get for us to start. And then you might have some where I have you fill in a matrix based on some given information. Okay? If you have any questions, let me know. But that's it for the basic matrix operations.